I have my genetic exam, and I have some doubts about Mendel.
Yeah, I have doubts about his life, and I don't know. I think I will fail the exam.
So true.
If only we had someone to ask about the experiments.
Hey, look, is he Mendel?
Hey, are you Mendel? Yes, I am.
Oh my god!
Oh my
Mendel.
god. Well, we are lucky because we have a lot of questions to ask you about your life, about your experiments, about all, all of it.
Okay, I can explain you everything you want.
I was born on July 22, 1822, in Heisendorf, Austria. Since my childhood, I had gone great in school. That attribute stayed with me even in my early adulthood, and I graduated from a 2-year program at the Philosophical Institute of the University of Olmütz in 1843. That same year, against my father's wishes to take over the family farm, I began studying to become a monk. I joined the Augustinian order at the St. Thomas Monastery in Brno. If you could just imagine, the monastery was full with researchers, teachers, libraries, and experimental facilities. I also studied mathematics, physics, and botany in the University of Vienna. In 1853, I returned to Brno, where they gave me a teaching position in the monastery. That was the time where my experiments began. Around 1854, I started my research about the transmission of hereditary traits in plant hybrids. I picked common garden pea plants for the focus of my research because they can be grown easily in large numbers and their reproduction can be manipulated. Pea plants can self-pollinate themselves or cross-pollinate with another plant, thanks to their male and female reproductive organs. I observed there are 7 traits that are easily recognized and apparently only occur in one of 2 forms in pea plants. 1. Flower color is purple or white. 2. Flower position is sexual or terminal. 3. Stem length is long or short. 4. Seed shape is round or winged. 5. Set color is yellow or green. 6. Pod shape is inflated or constricted. 7. Pod color is yellow or green. The experiments consist in selecting cross-pollinate purebred plants with particular traits and observe the outcome over many generations. In cross-pollinated plants that either produces yellow or green pea seeds exclusively, I found that the first offspring always had yellow seeds. However, the following generation constantly has a 3-to-1 ratio of yellow to green. I conclude 3 things. The inheritance of a trait is determined by units or factors that are passed on to descendants. An individual inherits 1 unit from each parent of each trait, and a trait may not show up in an individual but can still be passed on. With all of the 7 pea plant traits that I examined, one form appeared dominant over the other, which is to say it masked the presence of the other allele, which is called recessive. This is the law of dominance. For example, if a tall pea plant and a short pea plant are combined, the dominant allele, that is the one that gives the dull height, will show in the offspring, so the descendants will be tall. These observations can be summarized in 2 laws. According to the law of segregation for any particular trait, the pair of alleles of each parent separate and only one allele passes from each parent to an offspring. Which allele in parent's pair of alleles is inherited is a matter of chance. According to the law of independent assortment, different pairs of alleles are passed from offspring independently to each other. An example is that a pea plant's inheritance of the ability to reproduce purple flowers instead of white ones does not make it more likely that it will also inherit the ability to produce yellow pea seeds in contrast to green ones. In 1865, I delivered 2 lectures of my findings of the Natural Science Society in Brno. who published the results of my studies in their journal the following year, under the title Experiments on Plant Hybridization. In 1868, I was elected about of the school in which I have been teaching for the last 14 years, and my new duties kept me continuing an extensive scientific work. I have been always a religious man, being the monk I am, but the church brought me closer to science. The church gave me many resources for my experiments. Even the Botnap was advocate for the scientific study of the inheritance before I arrived. My predecessor at the garden, Matthew Clausel, had an interest in the study of peace. I had the full support of the community and nothing could make me happier. Sadly, some people accuse me of confirmation bias of seminal work on pea plants. There is some randomness of some reason in my results. I look at the inheritance trace as a random event and try to analyze the result based in probabilities. The importance of variability and its evolutionary implications were overlooked. No one seemed to care when my work was finally published, and well, I did little to promote it also. I hope one day people will look and appreciate my experiments and results. I believe they are useful, and maybe they can even change what we think about the world today.
Oh, yeah, this is very important. Thank you so much.
Thank you very much, and I just want you to know that your work is still important for us, and you are the father of the genetics.
Thank you. But there wasn't a girl there.